I'm getting the same error as you when I try to do.
Okay, I thought it was just me.
Yep. So docs getting started with cloning with HTTP URLs. Okay, that's what we want to look at. Um, I mean, you are getting there. I'm just trying to find out more information. Cloning with remote. So what is that message? Cloning with HTTPS URLs. Hmm. So what happened? Incorrect username or password. Why? I mean, you need to put the password, right?
Yeah, I've typed it like 8 times already, and the new one, and it won't let me.
Okay. So what is your password is correct, right?
Oh
Yeah, it
yeah.
should be, yeah. So if you enter, don't save. There have been several failures. Oh, I see. Wow. This is basically the IP address is causing the problem, probably. So, what is the way around? Let me think about it. Um, since your repository is inaccessible from there, so let's see how much we made progress. So we did the git push, it did not work. So from 15 to 24, it did not work. So basically, what we can do here, uh, okay. So what I would do is that I will try to find a solution and post it to the class. By that time, I mean, for now, let's uh, let's let's keep it until that before the push command, because everything else worked. I will try to find a process using your Linux Mint about how to push to a remote repository that works for the Windows system, but that doesn't work for the Linux Mint system. So I will find some solution and post it by, let's say, tomorrow sometimes. So I will work on that. Don't worry about it. Just complete your assignments until step number 13, and then I will give you the further instructions. Let's do a quick look up into our quizzes because that is something very important. Where is the quizzes? Because I mean the takeout journal, you can do it yourself because it's basically taking the notes from the lecture and make up your own notes addressing the specific questions. If you have trouble with that, message me. I will help you. But let's go to the quizzes. Let me share my screen, do a little bit touch base on the quizzes so that we address everything that we want to address here. So here, where is the modules? And let me go to the quizzes. So here it is week number 3. Yeah, chapter 3 quiz. So let me do the preview. So that is the one. Let me try to see the set the other interface as well for the quiz. So let me sign into the portal. So basically I'm trying to see the correct answer so that I don't confuse you a lot. So let me go to the modules and let me go to the quiz. Okay. So there it is. The questions. Yeah, that's fine. Okay. So the first question is, which of the following is the simplest memory abstraction? So the simplest one, I mean, it's in the slides, yesterday's slides, but don't want to confuse you. I mean, it is device drivers at the top of the memory in ROM. I mean, you will see the three different levels of abstractions we presented. So this is the one, this is the simplest one. Device drivers at the top of the memory in ROM. So the next question is basically, sorry, not this one. Major drawbacks. I mean, what are the major drawbacks of exposing physical memory to the process directly? That's what happened in the earlier Linux systems. So it can cause the system to crash. That's what it happened. I mean, a lot of times people crashed the system unintentionally. The first one is the correct answer to that. So what is virtual memory? So let's see. What is a virtual memory?
This is the last one, a way to run programs that are
Right, right.
too large to fit in memory.
Absolutely right. Yes, that's the correct answer. Yep. So which page replacement algorithm? Yeah, that's a page replacement algorithm is considered to be the best possible but unrealizable. So, I mean, the answer should be the optimal page replacement algorithm. I mean, there are many algorithms for that, but the optimal one. This is the best, but I mean, based on the, oh no, not this one. I mean, optimal is not that answer to that question. Is based on the principle of replacing the page. So that should be this one, the last recently used LRU page replacement algorithm. That's the replacement. I mean, so you can replacing the page that not has been referenced or modified recently. So that is the least recently used. It's a very famous algorithm, actually. Uh, what is the main drawback of the optimal page? So next question is, what is the advantage of using segmented memory for linking procedures? So we are talking about the segmented memory. The segmented memory, it says procedures can be modified and recompiled without changing the starting address or other procedures. So when you use the segmented memory for the linking procedure, it is quite dynamic. You know, the segmented memory segmentation, if you remember, we said the paging and segmentation. Paging is the fixed size, segmentation is the dynamic size. So you can recompile. You don't have to specify any particular I mean location, particular number. You can procedures can be modified and recompiled without changing the starting address or other procedures. It will adjust. So the last answer is the correct answer. What happens when two running programs in memory try to write the same memory location in a system with no memory abstraction? So that's a serious problem. So basically, they will crash, right? I mean, none of them can persist because you are overwriting on each other. So at some point, it will not find any reference for whatever it has done before. So they will have no way to continue. They will crash eventually. So which page replacement algorithm is used for evaluating the performance of other algorithms, but not practical for real systems? That's the optimal page replacement algorithm. This is the right answer for that. So how are base and limit registers used in memory abstractions? Base and limit registers used in memory abstractions. So map is no, it's not the right one. They provide separate memory, not right one. They automatically add a base value to the address generated by a process before sending it out on the memory bus. So third one is the correct answer. So that's the third one, which is correct. So next question is, what is the purpose of an address space in memory abstraction? Address space in memory abstraction. So
To map the
uh,
physical memory address.
uh, no, I mean physical location for which one to allow
Number 2.
to map the physical memory address to virtual memory address, address space in memory abstraction. No, I mean address space. No, that's not the that's the paging that's the page table that does it.
Oh.
So it is the provide a separate and independent memory space for each of the processes. So that's the abstraction. I mean, uh, that's the facility that they create. They virtualize the memory and then they put separate address space, separate memory space for each of the processes. What is the typical unit size paging of the paging? I mean, I think it's a 4 kilobyte. That's what we used, but let me confirm. So yeah, it's a 4 kilobyte. It's a smallest of whatever you get. The variable size would be the segmentation. So when you do the paging, so it's a fixed size virtual memory and it's a minimum. So what is the main advantage of virtual memory? That's a good question. Advantage of virtual memory. So allows programs to split into segments. No, it prevents access to memory address beyond the limit value. No, maps each program into its own address space. So that is the main advantage. So basically you can localize the program to its own address space. So the third one is the correct answer. How did early models of IBM 360? So what did it do? I mean, solve the problem of running multiple programs concurrently without memory abstractions. So basically by trapping attempts to access memory with different protection keys held in special registers inside the CPU. So basically this is the answer. I mean, I mean, it's, I mean, that's what we actually discussed in the first part of yesterday's lecture. So they created a diagram and then they showed that the protection keys, the importance of the protection keys. So that is the most important thing there. IBM 360 machine. What is the main drawback of the optimal page replacement algorithm? So drawback of optimal page replacement algorithm. So basically it requires hardware support now. So it is as we found before in another quiz answer, it is difficult to implement in real systems. So this is the right answer. Next, which of the following is a disadvantage of organizing the operating system at the very bottom of memory in RAM? So yeah, that's another architectural question. So basically provides no memory. OK, it can result in conflicts. It is rarely so all of the above. This is the right answer. Everything is true for this question. What is the segmentation in virtual memory? That's important. Segmentation in virtual memory. So a way to organize virtual addresses known as the technique to provide separate virtual address spaces for different tables in a compiler. I mean, basically, your separate virtual address spaces for different tables. So second one is the right answer to that. Which page replacement algorithm is based on the principle of replacing the page that has not been referenced for the longest time? So it should be the uh, uh, LRU, I mean, we already did that, I believe. LRU, let me verify it if I am right. So yeah, that is the LRU. That's what it says. I mean, that has not been referenced for longest time. What what is swapping in the context of running multiple programs without memory abstraction? So basically we have to refer to the swapping. So saving the entire context of memory to non-volatile storage. That is the one. The old operating systems used to use this. So how does segmentation facilitate sharing of procedures or data between multiple processes? So we are doing segmentation. So basically what do we do? Allowing procedures to be packed? No, that's not the way. Procedure, different kinds of protection. It's not related to protection. Linked independently. No, this is not also true. I think this is the true answer. By allowing a shared library to be put in segment and shared by multiple processes. So that's the main benefit of segmentation. Now, what is the purpose of protection keys in the memory allocation? So this is important. Protection keys. What is the purpose of what is that? Protection keys in memory abstraction. So to prevent access to memory address beyond, no, not that. Provide a separate memory space for each process to compare with executing processes protection key for memory access control. So this one, the third one, this is the security. Basically, it controls the access to different memories. So the user has to provide a key. I mean, that's the process within kernel, and then it will be compared before it is accessed. Why is the use of base and limit registers considered a simple solutions for memory abstraction? So basically it allows, no, not this one. I believe the fourth one is the correct answer. It prevents access to memory addresses beyond the limit values stored in the limit register. So when the word limit register is the key actually. So it is, I mean, all the other descriptions, they don't talk about limitations about something. So this is the fourth answer is the right answer. So basically we discussed the quiz answers. So whenever you do the quiz, you can refer to this lecture, to this part of the lecture, and just put it in your mark it on your answer. So you will learn it and you will uh, answer your quizzes at the same time, and quizzes have 2 attempts. So you can do 1 attempt and then you can see what are the wrong answers, and then you can go to the next attempt as well. So that's pretty much it is. I believe only one thing that we did not, 2 things we did not. One thing is incomplete, the Git. I will put all the instructions together tomorrow night, possibly. I will send an announcement with the instructions. And number 2 is we did not do the takeaway journal. So what is, I'm leaving it up to you. Basically what you need to do is go through the lecture, which you went through already, and just come up with the answers to the questions. If you are stuck, uh, just message me. I will help you with that assignment. So I think we are at the end of today's session. So any question?
Hey,
Any
sir, are
final
you gonna
question?
post that the GitHub piece on Teams, or will you do it in the files?
In the, I will do it as an announcement under the canvas.
Okay.
So yeah, you will look for an announcement today.
Copy.
Latest by day after tomorrow morning.
All
But
right.
it will be pretty soon before you even
Yeah,
upload your
I'm
assignments.
glad you went through that because I got stuck on it too. I couldn't
Mhm.
get, I got to get to load, but I couldn't get to sync the two. I
Okay,
appreciate
yeah,
that.
right. Okay,
All right, thank you.
thank you.
I thought I thought it was just me. I'm glad. I mean, I don't want anybody else to have the same problem I had, but I'm glad
Right.
I know it wasn't just me.
Yeah, yeah, that's true.
Have a good evening, sir. Thank you.
Okay, thank you. Talk to you soon.
So if I get
Yeah.
all the other assignments done except
Mhm.
for that one, and I did the quiz and the and the takeaway journal, if
Yeah.
I started the one we just did, the Git commands, would I have to do a lot of that stuff on GitHub over, or would I just be able to do the uh CD make directory given
Mhm.
and I probably would get stuck at number 13 again?
Push. Yeah, push.
Oh,
Because
okay.
it deals with pushing your content to the remote folder, and that's where the credential management, I mean, credentials are problematic there. We will have to get a solution to that. So
Oh,
that's the. Yeah.
well, at least this is a good way to understand it.
Yeah.
When I
Right.
was doing one of the assignments yesterday,
Mm-hmm.
I was like, it kept telling me I didn't have access. And it was like, oh, we did this. How did I do it? And we did it to where you had the thing with the Shiloh and the pound sign. Looks like the tic-tac-toe thing.
Mm-hmm.
And I remembered I had to put CH mode plus X and then the file name, and then it
Yeah.
worked. So I was like, oh,
Yeah.
please. I was gonna write somebody in the class and hope they answered, but then I looked on the internet and found it. So I'm like,
Yeah.
oh, good, it works. But I was like, I
Right.
can't get stuck now.
Yeah.
Like,
Yeah.
I'm glad. But thank you for trying to help with the with that Git commands one, because
Mm-hmm. Yeah.
I would really
We
got
will
stuck.
find. Yep.
Dang. I
Okay.
guess I better let you go since the class is over.
Sure.
Yeah. You
Thank
have a
you.
good night.
You too. Bye.
Bye bye.